PR.4, factoring polynomials, simplifying complex fractions, and multiplying by the conjugate. Southwestern College, Professor Maria Olivas. PR.4, factoring polynomials, simplifying complex fractions, and multiplying by the conjugate. Objectives: factoring polynomials. Apply factoring techniques to simplify rational expressions. 1. Multiplying polynomials. To multiply polynomials, use the distributive property. Example 1. Multiply each set of polynomials. A. We're going to open up a set of parentheses, 3x plus 5, close the parentheses, and then we have negative 4x being multiplied to that quantity. I'm going to distribute the negative 4x. So if we multiply negative 4x to the 3x, we're going to get negative 12x squared. And if we multiply negative 4x to the 5, we're going to get negative 20x. I'm going to box that answer in. B. We have the quantity 3x minus 2 multiplied times the quantity 5x plus 7. I'm going to use the box method to multiply these two binomials. I'm going to draw a 2 by 2 box because we have two terms in our first binomial and we have two terms in our second binomial. I'm going to write 3x minus 2 across the top of my box, and I'm going to write 5x plus 7 going down the side of my box on the left-hand side. 5x times 3x is 15x squared. 5x times negative 2 is negative 10x. 7 times 3x is 21x. And 7 times negative 2 is negative 14. And if I look at this, I have like terms here. 21x and negative 10x are like terms. So I'm going to circle those two terms together and I'm going to add those up. Our final answer here is going to end up being 15x plus 11x minus 14. And I'm going to box that answer in. Next, for problem C, we have the two binomials being multiplied together. We have the binomial 7m plus 4 times the binomial 7m minus 4. I notice that the only thing different between these two binomials is that middle sign. I'm going to use the FOIL method here. I'm going to start off by multiplying the two inner terms, the 4 times the 7m, and I'm going to draw a little half circle curve between those two, and I'm going to write 28m beneath those two to represent the product. Then I'm going to multiply the 7m times the negative 4 and draw also a half circle curve between those two. Underneath the 28m, I'm going to write negative 28m. And then I'm going to multiply the first two terms together, which is the 7m times the 7m, and I've drawn a curve between those two. That's going to give me 49m squared. And then I'm going to multiply the last two terms together, which is the positive 4 and the negative 4 together, and that's going to give me negative 16. Because the inner and the outer terms cancel out because I get the exact same term with opposite signs, I'm not even going to write down that term. I'm just going to write the 49m squared minus 16. I'm going to box that answer in. D is going to be the binomial 9x plus 4. That quantity is going to be squared. So I'm going to write this equals the binomial 9x plus 4 times the binomial 9x plus 4. I'm going to use the box method for this one. Since I have two terms in the first binomial times two terms in the second binomial, I'm going to draw a 2 by 2 box. And I'm going to go ahead and write 9x plus 4 across the top of my box with the 9x on the top of one of the columns and the 4 on top of the second column, and then 9x plus 4 across the side on the left-hand side with the 9x in front of one of the rows and then the 4 in front of the second row. 9x times 9x is 81x squared. 9x times 4 is 36x. 4 times 9 is 36x. And then 4 times 4 is 16. The like terms here are 36x plus 36x. I'm going to add those together and I'm going to draw a circle around those to show that I'm combining those. And my final answer is going to be 81x squared plus 72x plus 16. And I'm going to box that answer in. C. We have 2p times the binomial 3p minus 5 times another binomial p plus 7. I'm going to start off by distributing the 2p to the first binomial, 3p minus 5. When I multiply 2p times 3p, I get 6p squared. And when I multiply 2p times negative 5, I get negative 10p. That's going to represent my first binomial now. And that's going to be multiplied with the second binomial, p plus 7. I'm going to go ahead and use the box method. So I'm going to draw a 2 by 2 box. And I'm going to write the 6p squared minus 10p across the top of my box. And then the p plus 7 is going to be written down the side on the left-hand side of my box. P times 6p squared is 6p cubed. P times negative 10p is negative 10p squared. 7 times 6p squared is 42p squared, and 7 times negative 10p is negative 70p. I'm going to circle the like terms here, which are going to be the 42p squared and the negative 10p squared. Since those are like terms, I'm going to add those together. So my final answer is going to be 6p cubed plus 32p squared minus 70p. F. I have a binomial times trinomial. So I have the binomial 2x minus 3 times the trinomial x squared plus 5x minus 4. I'm going to draw a 2 by 3 box because I have two terms in that first binomial that I'm multiplying, and then the second polynomial is a trinomial and it has 3 terms. I'm going to write the 2x minus 3 on the side, on the left-hand side, with the 2x in front of the top row, and the negative 3 in front of the second row, and then the x squared on top of the first column, and then the x squared plus 5x minus 4 is going to go written across the top with the x squared on top of the first column, the plus 5x on top of the second column, and the negative 4 on top of the third column. 2x times x squared is 2x cubed. 2x times 5x is positive 10x squared. 2x times negative 4 is negative 8x. Negative 3 times x squared is negative 3x squared. Negative 3 times 5x is negative 15x. And negative 3 times negative 4 is positive 12. I'm going to enclose my like terms with a peanut-shaped looking circle. So I'm going to enclose the negative 3x squared and the positive 10x squared. And I'm going to also enclose the negative 15x and the negative 8x. And I'm going to end up with 2x cubed plus 7x squared minus 23x plus 12. I'm going to box that answer in. Our second section is on factoring. To factor a polynomial means to write the polynomial as a product of 2 or more polynomials. Here we have some examples. 5x squared minus 15x, we can factor out the GCF, which would give us 5x times the binomial x minus 3. We have x squared minus 36, which is the difference of two perfect squares, which will factor into two binomials. It'll factor into x minus 6 times x plus 6. And we have the trinomial x squared minus 12x plus 36, and that's a perfect squared trinomial, so that's going to factor into x minus 6 quantity squared. The steps for factoring. Step 1. You're going to ask yourself, is there a greatest common factor? And if so, factor out the greatest common factor, the GCF, first. Step 2. Count the number of terms. Is there 2 terms, 3 terms, 4 terms, or more? Step 3. Use a strategy consistent with the number of terms counted. A. If you have 2 terms, in other words, binomials. 1. Is it a difference of 2 perfect squares? If so, it's going to turn into a squared minus b squared, which is equal to the 2 binomials that are being multiplied together, a plus b times a minus b. 2. Is it the sum of 2 squares? If so, stop, because then this expression is prime. 3. Is it the difference of 2 cubes? If so, then a cubed minus b cubed is equal to the binomial a minus b times the trinomial a squared plus ab plus b squared. 4. Is it the sum of 2 cubes? If so, a cubed plus b cubed is equal to the binomial a plus b times the trinomial a squared minus ab plus b squared. B. three terms, or trinomials. Is it in quadratic form? And that form would be ax squared plus bx plus c. If so, try guess and check to factor into the product of two binomials. C, four terms. 1. Use factoring by grouping. Step 4. Check your work by multiplying the factors. So these would be the steps you go through when you are factoring out polynomials. We are going to start off with our first factoring technique. 1. Factoring out the GCF. The GCF of a list of polynomials is the largest expression that can be divided evenly into all of the polynomials. Steps to find the GCF. Step 1. Find the GCF of the coefficients of each variable factor. Step 2. For each variable factor common to all of the terms, determine the smallest exponent that the variable factor is raised to. Step 3. Find the product of the common factors found in steps 1 and 2. This expression is the GCF. So that would be the steps to find the GCF. The steps to factor the polynomial using the greatest common factor would be step 1. Identify the GCF of the terms that make up the polynomial. Step 2. Rewrite each term as the product of the GCF and the remaining factor. Step 3. Use the distributive property in reverse to factor out the GCF. Step 4. Check using the distributive property. Example 1. Factor 15y squared z plus 5y raised to the 7th z plus 20y cubed z. The first step is going to be to find the GCF of the coefficients of each variable factor. If I look here, I see that I have a 15, a 5, and a 20 for my coefficients. I'm going to go ahead and highlight those in yellow so they really stand out. So I'm going to start off by highlighting the 15, and I'm going to highlight the 5 and then the 20. So the GCF of those three coefficients is going to be 5 because 5 is the largest number that could divide evenly into all of three of those coefficients. Now I'm going to go and I'm going to look for the smallest exponent for all of these same variables. I see all of these terms share a y, and the smallest y factor is going to be y to the second. So I have circled this second power on that first term that has the y to the second, and I noticed that they all have z raised to the first power. So my GCF is going to be 5y squared z. So we are going to factor out that GCF. In order to factor out that GCF, I'm going to write 5y squared z first, and then I'm going to open up a set of parentheses. Now when I factor out a GCF, I'm actually dividing by that GCF into each one of these terms. So I'm actually going to show this step. I'm going to write down 15y squared z divided by 5y squared z plus 5y raised to the 7th z divided by 5y squared z plus 20y cubed z divided by 5y squared z, and I'm going to close the parentheses. So my final answer is going to be 5y squared z times, we're going to open up a set of parentheses, 3 plus y raised to the 5th power plus 4y, close the parentheses, and I'm going to box this answer in. This is going to be my factored out polynomial, where I factored out the GCF. Two, factoring a polynomial with two terms, no GCF. We're going to start off with the difference of two squares. If we have a squared minus b squared, this is going to be equal to the two binomials multiplied together, a minus b times a plus b. Our example 2. Factor 49x squared minus 36y squared. First, I must check to make sure that these are actually both perfect squares. So if I take the square root of 49x squared, so this is going to be the square root of 49x squared is going to be equal to 7x, which is going to be representing my a. And if I take the square root of 36y squared, so the square root of 36y squared is going to be equal to 6y, which is going to be equal to my b. Now we're just going to substitute into our little formula. So this is going to be equal to two binomials multiplied together. It's going to be, the first binomial is going to be 7x minus 6y times the second binomial will be 7x plus 6y. And I'm going to box that answer in. The sum or difference of two cubes. So here first we have the sum of two cubes. We have a cubed plus b cubed is equal to the binomial a plus b times the trinomial a squared minus ab plus b squared. For example 3, we're going to factor m cubed plus 27. First I need to make sure that these actually are perfect cubes. So I'm going to take the cube root of m cubed, and that's going to be equal to m, which equals a. And then the cube root of 27. 27 is just 3 factors of 3, so the cube root of 27 is going to be equal to 3, which is equal to b. So if I plug into that formula, that a plus b times the trinomial a squared minus ab plus b squared, this is going to give me the binomial m plus 3 times the trinomial m squared minus m times 3 plus 3 squared. Now if I simplify that trinomial, I'm going to get this. I'll still have that first binomial, m plus 3, and then times the trinomial m squared minus 3m plus 9. And that'll be my final answer. I'm going to box in those two factors there. And that's going to be the factors of my sum of two cubes. Now we have the difference of two cubes. So that's a cubed minus b cubed is going to be equal to the binomial a minus b times the trinomial a squared plus ab plus b squared. Example 4 says factor 64p cubed plus 1. First, we actually need to make sure that these are actually two cubes that we're subtracting. So the cube root of 64p cubed is equal to 4p. So that's going to be equal to my a. And then the cube root of 1 is just going to be equal to 1. And that's going to represent my b. So we're going to go ahead and just substitute into our formula. Here, first let me write the formula out. So it's going to be the binomial a minus b times the trinomial a squared plus ab plus b squared. Now substituting in, we're going to get for that first binomial, we're going to get 4p minus 1. And then this is going to get multiplied with the trinomial. It's going to be 4p inside parentheses squared plus 4p times 1 plus 1 squared. Now let me simplify that trinomial out a little bit more. We're still going to keep that first binomial the same, so 4p minus 1, and then we're going to multiply it with the trinomial 16p squared plus 4p plus 1. And close our parentheses there, and that's going to be our factors for the difference of two cubes. And we have boxed it in, so let's move on to the next example. Three, factoring a polynomial with 4 terms. No GCF. Steps to factor a polynomial by grouping 4 terms. Step 1, group the terms with common factors. Step 2, in each grouping, factor out the GCF. Step 3, if the remaining factor in each grouping is the same, factor it out. Step 4, check your work by finding the product of the factors. Example 5, factor 8x plus 16 minus xy minus 2y. I'm going to start off by rewriting that middle minus sign as plus a negative, because you want to be very careful when you have a minus sign in the middle here when you have 4 terms, because if you aren't, you might accidentally make it look like you factored out a negative when you didn't. So I'm going to write here 8x plus 16 plus negative xy minus 2y. I'm going to group the first 2 terms, which is going to be the 8x plus 16. So I'll draw parentheses around those 2 terms. And I'm going to group the second 2 terms, which is going to be the negative xy minus 2y. So we'll put parentheses around those 2 terms. The greatest common factor of the 8x and 16 is 8. So I'm going to write 8 times the quantity x plus 2. Now I'm going to factor out a negative y from the second 2 terms. So it's going to next say minus y times the quantity x plus 2. Now if we look here, we see there is a common factor of x plus 2. I'm going to factor out that common factor of x plus 2 from both of these expressions, and we're going to be left with x plus 2 times the quantity. I'm going to open up a set of square brackets. We're going to have 8 times x plus 2 divided by the quantity x plus 2, and then we're going to subtract from that rational expression y times x plus 2 divided by the quantity x plus 2. I'm going to cancel out the common factors of x plus 2 in these rational expressions, and we're going to be left with x plus 2 times the quantity 8 minus y. And we're going to box that answer in. That's going to represent the factors of our polynomial. Four, factoring a quadratic trinomial, 3 terms. A quadratic trinomial is a polynomial of the form ax squared plus bx plus c with a not equal to 0, where a represents the coefficient of the squared term. In this case, it's a second degree polynomial. B represents the coefficient of the linear term, the first degree part, and c represents the constant. Steps to factor ax squared plus bx plus c, where a is not equal to 0, and a, b, and c have no common factors. Example 6. Factor 4m squared minus 4m minus 15. I'm going to label my a, b, and c first. A is equal to 4, b is equal to negative 4, c is equal to negative 15. I'm going to use a factoring by grouping method to factor this trinomial. So I'm going to refer to this x that I'm drawing as the magic x here. On the top part of this x section, I'm going to write a times c, which is going to be 4 times negative 15, which is equal to negative 60. On the bottom part of this x, I'm going to write b, and I'm going to put a little plus sign under that b. And then I'm going to write a negative 4 above that b. I need to find two numbers that multiply to give me that product of negative 60, and the same two numbers need to add up to give me negative 4. Those two numbers are going to be 6 and negative 10. So I'm going to go ahead and use those two numbers to rewrite the middle term, the linear term of my polynomial. So I'm going to write 4m squared minus 4m minus 15. I'm going to highlight the negative 4m, and I'm going to put a red cloud around it. I'm going to draw 2 arrows going down from it. I'm going to rewrite this trinomial as 4m squared plus 6m minus 10m minus 15. I'm going to rewrite that middle minus sign as plus a negative. So I'm going to rewrite it as 4m squared plus 6m plus a negative 10m minus 15. Now I'm going to do factoring by grouping. I'm going to group the first two terms, the 4m squared plus the 6m, and I'm going to group the last two terms, the negative 10m minus the 15. I'm going to do factoring by grouping. I'm going to factor out a greatest common factor of 2m from the first two terms. So I will have 2m times quantity 2m plus 3 minus 5 times the quantity 2m plus 3. Now I'm going to factor out the greatest common factor in this case, which is 2m plus 3. So I'm going to factor out that whole quantity. In order to show this step, I'm going to write the binomial 2m plus 3 inside parentheses. Then I'm going to open up a set of square brackets. Inside the square brackets, I'm going to write 2m times the quantity 2m plus 3 divided by 2m plus 3 minus, and from that rational expression, we're going to subtract this rational expression, 5 times the quantity 2m plus 3 divided by the quantity 2m plus 3. And I'm going to close the square brackets. The 2m plus 3's cancel out in both rational expressions, and we're left with the factors 2m plus 3 times the quantity 2m minus 5. 3. Rational expressions. And I'm going to box that answer in. 3. Rational expressions. A. Simplifying through factoring. One requirement for a rational expression to be considered simplified is that there are no common factors in the numerator and denominator. Example 11. Simplify each of the following rational expressions by dividing out any common factors. So we're going to factor out these rational expressions, everything that we have in the numerator, everything that we have in the denominator, and cancel out any common factors. For a, we have 3x minus 12 over x squared minus 16. In the numerator, we can factor out a common factor of 3. So it'll give me 3 times the quantity x minus 4. And the denominator is the difference of two perfect squares. So I'm going to factor out that x squared minus 16 in the denominator as two binomials multiplied together, x plus 4 times the binomial x minus 4. And now I can cancel out a common factor of x minus 4 in the numerator and denominator, and I'll just be left with 3 divided by x plus 4. And I'm going to box that in. B. Simplifying complex fractions. Another requirement for a rational expression to be considered simplified is that there are no fractions within the fraction. To address this, we will multiply the numerator and denominator by the LCD of the inner fractions. Example 12. Simplify the following complex fraction. A. We have the following complex fraction. 3 over y plus 5, and from that rational expression we're going to subtract 3/5, and that's going to be all over y. So now, in order to simplify this complex fraction, I'm going to multiply by the LCD of the inner fractions. In that case, it's going to be 5 times the quantity y plus 5. So I'm going to put parentheses around the entire numerator of my big fraction, and I'm also going to put parentheses around the y in the denominator. Next to the numerator part, I'm going to write 5 times y plus 5 over 1. And then in the denominator, next to the y, I'm going to write times 5 times y plus 5. This is going to all be equal to, in the numerator of the big fraction, we're going to have this. So we're going to have two fractions being added together. In the first fraction in the numerator, we have 3 times 5 times the quantity y plus 5 divided by y plus 5. That's our first rational expression. Plus the second rational expression will be negative 3 times 5 times the quantity y plus 5 over 5. And I am going to have this written all over our denominator, which is 5y times the quantity y plus 5. So if we simplify in the numerator of the complex fraction, we can cancel out the common factor of y plus 5 in the first rational expression and the factor of 5s in the second rational expression. I'm going to distribute that negative 3 to the binomial y plus 5 in the second rational expression in the numerator. And so if I simplify this now, I'm going to end up here with 3 times 5 is 15. And I'm going to, since I'm distributing a negative 3, this is going to be minus 3y minus 15 all over 5y times the quantity y plus 5. The 15 and the minus 15 will add up to 0, and we'll just be left with negative 3y in the numerator over 5y times the quantity y plus 5. The y's will cancel out, and we'll be left with negative 3 over 5 times the quantity y plus 5. And I'm going to box that in. C. Dealing with radicals. If your fraction involves expressions with radicals, it is sometimes helpful to multiply the numerator and denominator by the conjugate of the radical expression. Conjugate of radical A plus radical B is radical A minus radical B. Example 13. Use multiplication by the conjugate to rewrite each of the following fractions. In problem A, we have 3 plus radical x over 9 minus x. We're going to multiply by the conjugate of the numerator. Conjugate of the numerator is going to be 3 minus radical x. So we're going to multiply by this to the numerator and denominator. So now this is going to be equal to, before I write this out, I'm going to use the box method to show the multiplication of the numerator part. I wrote a 2 by 2 box, and I wrote 3 plus radical x across the top and 3 minus radical x on the left hand side of the box. So we have in the top the 3 lined up with the first column And then the plus the radical x is lined up with the second column at the top, and on the side we have 3 lined up with the first row, and then we have negative radical x lined up with the second row. 3 times 3 is 9. 3 times radical x is 3 times radical x. Negative radical x times 3 is negative 3 radical x. And negative radical x times radical x is negative x. So going back to our expression and what it simplifies to, it's going to be equal to 9 minus x over 9 minus x times the quantity 3 minus radical x. And notice that here we're going to leave the denominator factored out as that binomial of 9 minus x times that quantity 3 minus radical x. We can cancel out a common factor of 9 minus x, and this is going to be equal to 1 over 3 minus radical x. And this is going to be our final answer, so I'm going to box this answer in.